Hey Flight Simmers, welcome back to a new episode of my Airbus A320 home cockpit build. My initial plan was to finish the whole overhead panel before I go on with the pedestal, and therefore I'm redesigning the Cori switches. I want to use some custom-made PCBs just for easier assembly, and the soldering is much quicker. And I already ordered some PCBs and did the soldering, but right now I'm not happy with the result yet. So I made the decision to go on with the pedestal. And once I'm happy with the redesign of the Coris, we will go on or come back to the overhead panel. So what's my plan with the pedestal? It's been a while since the last video with Autodesk Fusion, so it's a nice opportunity to focus on the more complex and mechanical parts of the pedestal, like the parking brake, the speed brake, and the flaps. In this video, I want to focus on the parking brake. The parking brake will be a series of 2 videos. In this video, I will do the design in Autodesk Fusion, and in the next video, I will do the assembly and the connection to the flight sim. Let's have a closer look on the parking brake. Of course, it has the same mechanism like the real one. You have to pull the lever, then you're able to turn it. And once you have reached one of the 2 positions, it will snap back into the locking position. So this whole lever is spring-loaded with this little spring on the backside. On the backside, there is a little gear mechanism. So on the inside there's a potentiometer. We have a closer look on the inside in a second. So I'm using a potentiometer, and this potentiometer is driven by this gear mechanism. And I tried several other solutions with read or Hall sensors with little magnets to identify the 2 positions. But the gear mechanism, in my opinion, it's the easiest solution to do it. And later in MobiFlight, I will just use an interpolation modifier to identify each of the 2 positions just by the resistance of the potentiometer. So this is actually the 3rd iteration of this parking brake. So I always have to keep in mind that I have to do a video about it and how to design it. So I want to keep it as simple as possible. And even the gears are really easy to design in Fusion. We will have a closer look on it today, and I will use gears as well for the flaps and the speed brake. And even it's the 3rd iteration, it's not perfect yet, because you can see over here there's already a little crack in the area of the nut. So in this design today I will reinforce it a little bit. I will do this leg a little wider so it has a little bit more strength. Let's have a closer look on the inside. Here's the potentiometer, and on the axle there is this little lock, this black item over here. It just snaps into one of the 2 pockets on the 90 degrees points, and there are 2 end stops to prevent the axle from turning beyond these 2 90 degrees positions. So a very simple mechanism, but it works really well. To keep this video as short as possible, I will not go into the design of the labels. We did it so many times for the overhead panel, so if you want to know how to do this, just watch one of the videos of the overhead panels. I will also not go into the design of the lever. Just follow the link in the description box. There you can download the lever for free. In the description box you will also find a link to the full printing data for the parking brake. If you are new to the channel, please subscribe and hit the bell. And now let's go into Autodesk Fusion and do the design for the parking brake. Here we are in Fusion. I already started a new document and saved it as parking brake. And as usual, I will start with importing the template for the panel. Browse to my YouTube templates, and in there There is the panel, just drag it in there. Just hit OK. I don't need the stance, just the blank panel. And before I'm able to change the size, I have to break the link. Right click on panel and break the link. And now under the Modify tab, I can change the parameters. I will change the width to 95 and the height to 85. Like this. In this tutorial, I will not show how to create all the labels on the top component. I did it several times on the videos for the overhead panel. So if you have a closer look on that, please watch one of the overhead panel videos. In there, I will explain in detail how to create all the labels, but I want to keep this video as short as possible. So I will not create the labels. On the top component, the parking brake, I will create one global sketch on the top face. Either select this global XY plane or the top of the panel. And in here, I'm creating a circle as a construction line and give it a dimension from the outside 35 and from the bottom 30. This will be my reference for all the other components, like the axle in the middle and the lock and the gears on the bottom. So this is my design of the parking brake you've just seen in the introduction. And the benefits of a global sketch with these dimensions is that all the other components are relating to this one sketch. So when I designed this one, I noticed at some point that I was a little bit too close on the right edge. So it's very easy. Just go back to the global sketch, the first one, and change the dimension 40 by 35, for example. And as soon as you're finishing the sketch, everything else will switch to the new position. So it's very convenient with this one global sketch that all other components are relating to. I will go with 35 from the right edge and 30 from the bottom. Finish the sketch. And I will start with the inside of the panel. Just switch off the visibility of the top component. And in here, I will create the pocket for the lock first. So make this bottom component active and create a sketch on the top plane. And first I will project this circle from the global sketch in here to my bottom. Just press P for project or create, and project include project. Here is the shortcut as well, P, just press P. This circle, okay. Switch off the visibility of the global sketch. And here is the circle. Define it as a construction line. Okay, and now I will add some more geometries. .5 millimeters in diameter on the inside. This is where the axle goes through this bottom panel. This outer is 15 millimeters. Create a horizontal construction line from the middle to the right. And a regular line this will be the lug profile. Add a symmetric constraint between these two lines and the center line. And now these two lines are symmetric to the center. Give it a dimension. $10 mm. And from the inside, 15. Okay, I will create the end stop as well, just with a 2-point rectangle, the profile with 5 by 5 millimeters. Here I'm not able to change the width because it will be over constrained. So in this case, I have to figure out which constraint is already there. And when you have a closer look on this endpoint, you can see there are two constraints. One constraint will be the height, and one is it's locked to the circle. So let's change, or let's delete this constraint. And now I'm able to change the width to 5 millimeters, like this. Okay. I need these profiles on this side as well. For the log profile itself, I could go with a circular pattern over here, or just do the same again with drawing the lines and the center line as well. But there are several ways to do this. You can either use a circular pattern with these 3 lines. The center point will be this one, the quantity 2, of course, and then we have to change the distribution to partial, and then change the angle to 90 degrees, quantity 2, and here is the profile. This will be, or this is one solution for this. I create another construction line with 45 degrees from the center line. Just delete these 3 lines, because the end stop, it's not possible to do it with a circular pattern, because then this end stop will be in this position, and then it's not possible for the log to reach the upwards 90 degrees position. For this case, I'm using this construction line, 45 degrees, and use the mirror again with these profiles, and the end stop to the mirror line is this one, and now the end stop is on the upper left. Hit OK, and this is the profile. Finish the sketch, and let's do some extrusions. I will start with the inner hole, just all the way through, like this. Then the pocket for the log, these 3 profiles. $8 downwards, and the end stops 5 upwards. And because there's the opportunity that you apply a bit of force to the end stops, I would recommend to add a fillet to the outside. So this is a little bit reinforced everywhere where, or every component where is force applied to, you have to prevent sharp edges, like you have in this case over here. It will snap at this position. So add a fillet and you're safe. These are the end stops. And now this one is already done. You can add some more Phillips if you want to for these edges, for example, 1 millimeter, just if you want to. It's not necessary. Okay, and the last thing I will do on the bottom, let's go to the sketches and switch the visibility. Now I will do this one in a second. First, I go back to the global component, make it active. And now let's create the lock. Right click, new component. The lock, I'm using the sketch I just created in the bottom component and use it again for the lock. Project the geometries like this. Oh, I have to create a sketch first. Create a sketch over here. And now I'm able to project the geometries. Okay, now I have the profiles for the lock. There is one profile missing. It's from the center hole. All right, this is a profile for the lock. Finish the sketch. Extrusion. Then change the start to object. Select the low face of the pocket. And from there, 5 millimeters upwards. This is the lock. Then for mounting the lock to the axle in the middle, I will create a little hole over here, just on the center spot. For this, I create a construction line. And on the center point of the construction line, a hole with 4 millimeters in diameter and all the way through. Let's add some fillets. 1 millimeter over here. Two millimeters over there. And some chamfers. Modify, chamfer, the upper face and the lower face. 0.25 millimeters. And now the lock is already done. Let's go on and modify the bottom a little bit, because you can already see over here, this fit is too tight. There is no gap between the lock and the bottom panel. So and here where I added the fillet to the lock, there is too much material over here. So let's change this, just make the bottom active again. And I will use the press pull for all the faces inside this pocket. Press pull, select all faces. Change it to -0.5. And now there's a little gap between the bottom and the lock. All right. And one more thing for the bottom, for the assembly, for drilling the hole into the axle in the middle, I will create a little hole in there. I will use it for the assembly. Just create a sketch on this face, project the geometry of this hole, and in there create a hole on this face in the center. Oh, okay. I'm not able to select the center of the circle because it is not a circle, because I selected that's very good for this example. I selected for the projected geometry this circle. From this perspective, it's a regular circle, but it's on a rounded face. So the result will not be a circle. So I have to select this one on this face. This face is flat, and the result should be a circle. And there is a center point. Okay, very important, keep in mind, if you project a geometry and you need a center point, don't select the geometry on a curved surface. Always select the geometry on a flat surface and you will have a regular circle with a center point. And now I'm able to select this center point for the hole all the way through, a little bit more over here, with a flat bottom, and the diameter I go to 4.5, just a little bit wider than the 4 millimeters of the lock. But be careful, objects to cut. You can see there is this bottom component. This is okay, but I don't want to cut the body of the lock. You can see in the preview, as soon as I enable the checkbox, this hole will be larger. So very important, I want to keep the 4 millimeters in the lock, but a little bit wider with 4.5 in the bottom. Okay. And now I have this hole for the assembly. I will drill the hole into the axis in the full assembly with the lock complete in this position. It's much easier than just measure the position of the lock and then hopefully get the 90 degrees to the handle. It's much easier this way. All right, disable the sketch, and now here we are. Yeah, this one is finished. Okay, let's go back to the main component and let's start with the gears. Create a new component, name it gears, and in here I will create both of the gears. Let's start with the larger one. In here, I'm creating an offset plane of the bottom, 12.5 millimeters downwards. And in here, let's create a sketch on this plane. And again, just project the circle of the global sketch. Now we have the position. Finish the sketch. And now let's have a look on the gears. It's actually pretty simple to create gears in Fusion. For this, switch to the Utilities tab, and then in there you can run some add-ins. Okay, and here I already have the search field filled out. And as soon as you insert spur, you have the spur gear. And I'm using this one. Just press the play button, either this one or this one, doesn't matter. And it might be that you have just one of them. Just press play, and then you have the spur gear window opened up. And in there, we have to do some, or have to assign some dimensions. In my case, it's still metric, pressure, angle 20 degrees, and the module I changed to 1. The module in gears is not a specific value. It's some relations inside the tooth profile. Don't care about it. Just change it to 1. The number of teeth will be 30. And here you can see the pitch diameter. This is the center diameter of the gear is 30. When I change the module to 0.5, it's 15. So let's do it for a quick example. Module of 1, number of teeth are 30. The backlash is very important. It creates a little gap between the teeth of this gear and the second gear. So give it a little bit of backlash, just 0.2 millimeters, and the gear will run a little bit smoother. The root fillet radius is the fillet on the bottom. It's too large. You have this or this notification. The root fillet radius is too large. Must be less than 0.59. Let's set it to 0.25. The gear thickness 5, and the hole diameter is 6. Okay, let's use these values. Press OK. And now Fusion is creating a gear. This one. This already looks pretty nice. Let's create another one, just for example. Again, in the field, just insert spur gear, run the add-in. And now let's change the module to 0.5 with the same other values, but you already see the pitch diameter is 15 now. This one is 30. And with the module, you can control the size of the teeth. So in this case, I will use a module of 1 because it's much simpler with the dimensions, because you can define, or the result of the pitch diameter is the number of teeth multiplied by the module. So pitch diameter 30 and 30 teeth. It's much simpler, and a larger tooth is always a little bit easier to print. So just go with module 1, number of teeth 30, a little bit of backlash for a little gap between the teeth of the both gears, root fillet radius, gear thickness, and the hole diameter. Press OK, and the result is the gear. For placing the gear, I'm creating a joint on the solid tab. Where is my joint? Assemble, and here's a joint, or simply press J from this circle to this circle. If you don't, so we need to have the 12 millimeters in between the bottom face of the gear and the bottom panel. So if this is not the case, just flip it like this. And now when you select this one, press Control and the lower face of the gear. Minimal distance 12.5, like I defined in this plane. Okay, here's the gear. Let's modify it a little bit, make it active, create a sketch, add 2 more circles. Let's set it to 10 and 15. Both profiles 10 millimeters upwards. And the inner profile over here downwards to create a little pocket where the spring can enter to. When we pull up the handle, the spring has a little bit of space that it can retract into the gear. So just create a little pocket. For the spring, I just use a little spring I found on Amazon. It's a diameter of 9 millimeters. So it's just a regular spring. You can create this pocket a little bit larger. So let's change it to 12. So just get the spring you find on the internet, and the pocket will be large enough, 12 millimeters. Okay. And one more extrusion for mounting the gear to the axle. For this, I'm creating an axis through cylinder here, and on this axis I'm creating a plane at angle. Okay, it's already at the right angle. Create a sketch over here, circle of 4 millimeters in diameter, create a vertical constraint to the center point, and from the bottom 5 millimeters right in the middle. This whole extrusion, this boss is 10 millimeters, 5 millimeters just in the middle, and one more extrusion. Symmetric to both sides. Okay, here's the gear. And these teeth over here on the right side are not necessary actually. So I can get rid of it. Just create another sketch. Create some lines like this, a construction line in the center, horizontally and vertically. Ten degrees over here, and create another circle. The dimension doesn't matter, as soon it's a little bit larger than the outer diameter of the gear. Set it to 35. It's totally fine. And now I'm able to select this profile. Now there's still one profile missing, I guess. So let's get back to the sketch and create a projected geometry of this diameter. this profile downwards. Like this. Create a fillet over here and over here, 5 millimeters. This tooth looks already fine, but over here I want to delete this whole profile of this tooth. Just select all the faces. Right click and delete. Okay. And some more chamfers here and on the bottom. Okay, this gear is finished. Let's add the second one. For this, I will create another sketch on the bottom face of the bottom component. Create 2 circles, one over here and one over here. This one is a diameter of 30, so it's the center of the tooth of this gear. This one will be 10. Create a tangent constraint between these 2 circles. This one I'm still able to move. Add a horizontal constraint, the center point to this one. Now the line is black. I'm not able to shift it anymore. All right. And now I'm creating another gear. Go back to the Utilities tab, Add-ins, Spur gear, Run. And in here, the number of teeth, change it to 10. The rest is identical. The module to 1, that's very important. We have to use the same module for both of the gears, otherwise it will not work. And the height, set it to 22. Gear thickness 22. The hole diameter is 6 millimeters for the axle of the potentiometer. It's 6 millimeters, so I will keep this. Just change the gear thickness to 22, the number of teeth to 10. The module is still the same, the backlash and the root fillet radius. Hit OK. And here is the second gear. Add a joint, press J, or in the solid tab, assemble and joint this circle to this one, flip it if necessary, and move it upwards 4 millimeters, like this. Now the teeth are not aligning. Can, if you want to, just change the last joint over here. You can rotate this gear, but it actually doesn't matter. Like this. And here you can see the backlash. There's a little gap between the teeth of 0.2 millimeters. If you don't apply the backlash, these profiles will touch each other. So please keep in mind to add a little bit of backlash, then the gear will run much smoother. All right, I will give it a little bit more strength because you can see there are very thin walls between the center hole and the teeth, and this is already the top position of this gear. So when we pull the handle, it will move downwards over here. So on the upper position, there's enough space to give this 10 teeth gear a little bit more strength. Just make it active, create a sketch. Create a circle. Select this center point of one of the tooth. Finish the sketch. Create an extrusion. Oh, okay. Quite common mistake. I selected, okay, don't select one of the teeth for the diameter of this profile, because now I have to select all of the profiles. You can either do this, or if you make the diameter a little bit larger, let's delete it and create a new circle and make it a little bit larger, 12 millimeters. It's right in the middle, okay. And 12.25, now it's a little bit wider. And if you do it like this, you're able to select the whole profile. And now I'm selecting for the extend type, the object, this one, this face, change the operation type to join and give it an offset of 2 millimeters. Like this. And now we have a little bit more strength in this small gear. Okay, now the gears are finished. As you have seen in the introduction, I created this little cage around it to give it a little bit more strength. Let's do this next. Go back to the main component, new component, and cage, for example. Create a sketch. I will use the top face of this gear. Now I'm creating some lines, the profile. Something like this. Let's project some geometries. The center of this one and the center of this gear. Add a coincident constraint between this construction line and the center point, and one more construction line and the center. Symmetric constraint between these lines and the center, and these two lines and this center line. This one is still movable. I'm just adding a coincident constraint of this line to this endpoint. And now when I change the size, this line will follow. Dimension, the original one, which broke was 10 millimeters. So go with 15, give it a little bit more strength. Width, change it to 12. From this center to the outside, 6 millimeters. $15. And over here a little bit more. Set it to 20, because in a few minutes we will insert the potentiometer. Give it a little bit more space for the potentiometer. Now it's actually on the inside, I guess. No, we will see. Some horizontal lines. Five millimeters from the outside. And in there, 2 lines where the nut is inserted. Add some symmetric constraints. The distance 7.2 millimeters. And either add another dimension on the top or just create a coincident constraint from this line to this endpoint. And now if we change one of the pockets, the other will follow. 7.2. Okay. Let's create some extrusions. Let's start with the outer side. Extend type to object, the bottom face, and from there, -2 millimeters into the bottom. I will create a pocket in there. New body. Okay. Then the pocket for the nuts. Offset -10 millimeters. From there, 5 millimeters downwards. Let's change the offset to 15, a little bit more, 18, 20, like this. There we will insert the self-locking nut. Now go back to the sketch. Oh, no, I don't. Finish the sketch, and in there, let's create some holes. Now I have to create some center points for the holes. Finish the sketch. Create hole. This face right on the center over there. Diameter 4.5 all the way through, even through the bottom. So objects to cut, the cage and the bottom. All right, and one more time on this surface, select the center point, 4.5 millimeters. Okay, one more extrusion. I already see that there's one profile missing. go back to the sketch, press P for projecting this inner circle, go back to the last extrusion, okay. Before I'm adding some fillets to this part, I will go to the bottom over here and create a combine from this bottom. Use this as a tool and change it to cut. Very important, keep tools. I want to keep the cage. And now I've created the pocket. Go back to the cage. And now let's add some fillets. All right, maybe a chamfer, 0.5 on top. Okay, now the cage is finished. One more step. For the bottom component, we have to insert the potentiometer. It's quite easy. Just let's go back to the global component, create another sketch and project the geometry of, or the inner diameter of the small gear. And now I'm using the potentiometer template. This one, just drag it into the view. I don't need the knobs. Okay, and now just create a joint. Press J between this circle and this one. Flip it around like this. There we can already see that might be an issue. And drag it a little bit downwards, 2 millimeters into the part, like this. Go back to the bottom and create a combine with the cut body. Okay, now created the pocket or the potentiometer, and one more pocket. It's necessary because the potentiometer is on the inside, so I have to feed the wires to the outside, and I'm creating a sketch on the inner pocket. I'll just create a horizontal line, 6 millimeters, and create an extrusion all the way through, like this. Okay, and this is a little bit tight over here between the pocket and the hole. Let's go back to the cage and edit the sketch. Just give it a little bit more space over here. 23. Finish the sketch. This looks much better. Okay. Let's change the position of the DC jack, because here are the labels for the parking brake. So it would be nice to have it in this region. On the bottom, there are no labels. Okay. Close all the components. Switch off the sketch. I don't design the axle. It's just a simple 6mm pipe. But for now, looks very good to me. Let's bring back the gears like this. So the potentiometer is in there. The two gears, the cage, the mounting holes for the cage. We could create a pocket for the screws, but it's actually not necessary. So at this point, we are finished. There we are. The design of the parking brake is done. Next step in the next video is to do the assembly and the connection to the flight sim. As you have seen, it's quite easy to handle gears in Autodesk Fusion, and we will use it quite a lot in the future for the flaps, the speed brakes and the gear lever as well. The printing data is available under the link in the description box. If you're new to the channel, please make sure to subscribe and hit the bell. If you find this video useful, please give it a like, and I hope to see you in the next video.